Hello. So in this video, we are going to be talking about graphing absolute value functions. And it turns out this actually isn't its own thing. So in particular, graphing absolute values, it's really actually just the process of graphing piecewise functions, which we've talked about already. So in essence, really the whole thing is just taking the absolute values, converting it into the piecewise function, and then taking that piecewise function and graphing it like any other piecewise function. So we'll do some examples and make some important observations about sort of how absolute values tend to look, but really the process is just the same as the piecewise function. So let's take an example here. So we have the absolute value 3x minus 2, all plus 1. So we would take this thing, right, convert it to the piecewise function. So we take the inside, figure out when that thing is non-negative, which gives us x greater than or equal to 2/3, write down the piecewise version of this, right, with that transition. And then we would graph this just like piecewise functions. So we graph the minus 3x plus 3 part in the relevant domain and then the 3x minus 1 part. Now, you'll notice, right, so we have like this dotted line here showing us where our transition point is. But you'll notice that sort of another very common property is that we seem to be bouncing off of some horizontal line here. So in particular, this horizontal line, this tends to occur where the absolute value part of the expression is 0. So here, right, at the transition point 2/3, that's when the absolute value inside was 0, which gives us 0 plus 1, which is just 1. That horizontal line part is where we usually tend to like bounce off. It looks like it's reflecting in some way. Now, depending on the nature of the function inside the absolute value, it may bounce off in weird ways. It may look like it's sort of skipping like a rock on a pond, for example, if you have like a high degree polynomial or whatever. But it does give this sort of sharp change in direction most often. And this is actually important to notice for calculus moving forward. Another important thing to note is that although absolute values do indeed always make things positive, that doesn't mean the graph has to be positive, because the absolute value is only part of the expression. So for example, if we look at this function here, right, minus 2 times absolute value of 1/2 x plus 1, all minus 2. A way we might sort of think like quickly here that we would get some sort of negative graph is the fact that we take the thing that's always positive, this absolute value, but then we multiply it by -2. So we're sort of abusing the fact that we have a positive value, and then we make it negative, right, always. And so that's what's going to end up making it a negative graph. But nonetheless, in terms of actually graphing this, same process. We convert it to this absolute value to the piecewise version, and then we graph the piecewise version. The thing we end up getting looks like this, right, where again we have this telltale sort of horizontal line that's occurring when this inside bit is 0, right? So 0 times -2 is 0, -2. So we get that y equals -2. And it seems to bounce off of that thing. But here, the entire graph is negative, right? So just because we have an absolute value doesn't mean that it has to be positive values. It doesn't necessarily have to go up. It doesn't even necessarily have to have any positive parts at all, like this one doesn't, okay? That just has to do with, a part of the function, not the whole thing. All right, so what do? Well, we talked about graphing absolute values and the fact that in reality, graphing absolute value isn't sort of a special thing. In fact, it's really just graphing piecewise functions with that little conversion part at the beginning where we go from absolute value to piecewise. But other than that, it really is just graphing piecewise functions. There is sort of a special feature of absolute value graphs, which is that nature of bouncing off of some horizontal line, which pretty much always happens. There's an asterisk there, right? There are special occasions where it doesn't happen, but pretty much always happens. And this is sort of noteworthy because this ends up being a really important feature about absolute value, especially if you go into calculus. Okay, so that is that.